Welcome back everybody. Today we're going to be having a look at Siemens STEP7 timers, both the S5 style and the S7 style. And what we're going to be showing you is how to use them inside of programs, their pros and their cons. Let's get started. So what we're going to do is we're going to open up Semantic Manager. And it'll open up with our last program from last week, which was our test program where we created a brand new project, created its hardware configuration, and then designed a very basic program. So if I just go to our Semantic 300 PLC and I double click hardware, we should see inside of here, there is our hardware configuration from our PLC, which was the CPU 314IFM. It had a 32-way input card here, it had a 16-way output card here, and a 4-way analog output card in slot 6. If I just close that down, I'm then going to go to blocks on the left hand side, and then I'm going to double click OB1. And inside of OB1 is the program that we created last week. Now what I'm going to do here is I'm going to delete network 2 and network 3 and just leave us with network 1, which was just our process run latch control. And then I'm just going to save our work and then download this to the PLC. So this way we have a fresh program inside of the PLC, something for us to start from. Now with Siemens STEP7, your timers are located in your left hand window pane, which is your instructions window pane. And if we open up our timers folder, you'll see there we've got 10 timers available. We got our pulse timer, our extended pulse timer, our on-delay timer, our LatchedOn delay timer, and our off-delay timer. And then you also have the S7 version of these timers below. And we're going to show you each of these timers and how they can be used in today's industries. So we have our latch here, which is just a standard start-stop latch going to our process run. We have our M bit, which is our start push button, our M0.1, which is our stop push button, and then we've got M10.0, which is our process run latch. And this is then going to control the program, control our timers to show us how they're going to run. Now what I want to do is I'm going to create a brand new network just by clicking the new network icon. And that creates our network 2. And then I'm going to use the normally open contact and tie that to M10.0, which is our process run contact. And then I'm going to drag in our very first timer, which is going to be the on-delay timer. And the reason why I'm going to show you this timer first is because this timer is available inside of all PLCs. So any PLC that you go to work with, any software that you're working with, has the on-delay timer. That necessarily can't be said for the other timers, however. So let's just drag and drop in our S_ODT timer. We had a look at this last week, but we're just going to show you this again. And it asks you for two things to start with. It's first of all going to ask you for your timer number. So we're going to give it the very first timer number, which is T0. And then it's going to ask you for our timer value. And for our timer value, I'm going to set this to 10 seconds. Now remember, with Siemens STEP7 timers, you must use the code S5T#. That there tells the PLC that this is a time value. And for 10 seconds, all we need to do is just type in 10S. There we go. And there's our timer value inside of there. Now, S stands for seconds. If we wanted milliseconds, it would be MS. If we wanted minutes, it would be M. And if we wanted hours, it would be H. The maximum value for these timers, I believe, is 2 hours and 46 minutes, however. Now, usually we wouldn't run timers for that long anyways. So we've got our 10 seconds timer sorted here. You'll also notice there are other inputs and outputs to this timer that we can assign. You've got your R, which is a reset, which we don't need for this timer, and I'll show you why later on. You've got your Q, which is your output. Now what we can do here is we can tie this to an actual output bit, just by clicking on the coil, and tie this to Q4.0, our very first output coil. Now, as I mentioned in last week's episode, you don't necessarily have to tie the output coil to the output of the timer itself. What you could do is we could branch down and assign a contact to T0, and that would work exactly the same as what we're doing up here. When T0 turns on, that contact will close and it will turn on any output coil that we want. I'm just going to then just delete that and delete this branch down here and just leave it with our contact going to a timer, going to a coil. Now what I'm going to do as well is I'm going to design the S7 style of that timer directly below it. So create another network, and again assign a normally open contact to M10.0 just like we have above. And the S7 style of the ODT timer is the SD timer. Drag and drop the SD timer into place and you'll notice it's similar to an output coil. This is the S7 style, it's a sleeker design. Now just like our on-delay timer, it asks you for two variables, a timer number. Now because we're using T0, we're going to use T1. And it's asking you for a timer value. Now a lot of people assume when they're working with S7 timers, because S5 timers use the timer code S5T hash, that they must use the timer code S7T hash. But if we typed in S7T hash 10 seconds and entered that to our timer, you'll notice it goes red. This is because it's not accepted. Again, even though it's an S7 timer, what we must use is S5T hash 10S. Unlike our on-delay timer up here, where we have an output coil directly after the timer, we can't do that with this timer because the timer itself is the output coil. If we wanted to address a coil to the output of this timer, then what we must do is similar to what we did before, which is branch down, add a normally open contact, and tie it to the timer itself, which is T1. Enter that, and then tie that to your output coil, Q4.1. I'm using the next lamp available. So what we're going to do is we're going to save this, and then we're going to download that to the PLC. And then I'm going to go online, click monitor. And it takes you online to the PLC. So here what's going to happen is when I right click my start push button and I say modify it to 1, the contact will close. It'll then turn on our process run output coil and latch it on. That will then close the contact to the timers in both networks, and both timers will run for 10 seconds. After 10 seconds, the outputs to the timers will turn on and then turn on our lamps. So I'm just going to right click our start push button, modify that to 1, modify it back to 0. Our latch is now active, and as you can see, both timers are now running. 3, 2, 1, and both outputs now turn on. If I reset the latch at any point, however, the contact will open and turn off the output coil M10.0, which will turn off the input signal to both timers and reset both timers back to 0. These timers require an input signal on at all times for the timer to run and execute. If the input signal turns off for one PLC scan or anything longer than that, the PLC will reset the timers back to 0. So it's important to remember that when working with these timers, that they don't retain their information. Now what can we use this on the shop floor for? Now one of the most common instances is a valve and pump. If we've got a valve on the shop floor and a pump on the shop floor, and we need to open the valve first before the pump turns on to reduce any back pressure on the valve, then what we do is we turn the valve on, wait 5-10 seconds for the valve to fully open, and then turn on the pump. And to do this, we would use an on-delay timer. Now you might be saying, well, we've got feedback signals on the valves. Well, that's great. If you have got feedback signals on the valves, then you don't need to use a timer. But if we don't have feedback signals on the valves, then we could use a timer to detect when it's fully open or when it's fully closed. And that there we would use an on-delay timer for. Now the next timer that we're going to be having a look at is the off-delay timer. So what I'm going to do here is I'm just going to come offline, and then I'm going to delete the ODT, and I'm going to delete the SD. And I'll delete the contact and the coil for this guy. Now the off-delay timer is this guy here, which is S_off-DT. And if I just drag that into place, and again it's going to ask me for two signals. It's going to ask me for T0 for the timer name, and it's going to ask me for the time value. Again, I'm going to leave this at S5T hash 10S. Everything else I'm just going to leave as blank. For the S7 style, it is SF that we use. And again, it asks you for two variables, T1 for the timer name, and S5T hash 10S for the timer value. And what we're going to do here is I'm going to create a new network, and I'm going to create a contact going to a coil, and I'll show you why. And this contact is going to be the T1, and this is going to then be the Q4.1. Let's save and download our work and see what happens here. go online with the goggles. Make sure the networks all wake up. There we go. Now, here we can see both timers are off currently, both output coils are off currently. What I'm going to do is I'm going to enable my start push button and then just disable it. And as soon as we've enabled that start push button and the process run is turned on, the timers have become enabled, but so have the actual outputs themselves. The outputs are already on. If we look at the timers, the timer values are 0. They haven't ran yet. What an off-delay timer does is it waits for the input signal to the timer to turn off and then turns off the output signals after the period of time has run. So for us to show you this, I'm going to reset this latch, and there we go. You can now see the timers begin to run and the output coils remain on. And now the output coils have turned off. So what it did there was it waited for the input signal to turn off. It then ran the timer for a period of time and then turned off the output coils after the time value had elapsed. When working on the shop floor, a lot of the times you might see extractor fans. When the process is running, you must have those extractor fans running. So here, if I just start my process, there we go, the process is now running. And let's just say that these are extractor fans instead of lamps. So what we have is we have this extractor fan on here, this extractor fan on here. When the process is stopped, what we want to do is we want to keep the extractor fan running for a period of time. A good example for this is at a sawmill. When you're at a sawmill, you're cutting up wood, you get a lot of sawdust in the air, there's a lot of dust floating around, so you've got extractor fans to clear that up so it's less hazardous for the operators. When the process is stopped, the sawdust doesn't just settle within seconds. It takes time for it to fall to the ground and then completely settle. So what we do is we continue running the extractor fans for a period of time to clear up any excess sawdust until the sawdust is completely settled after a period of time, and then stop the extractor fans. So if I just stop this process now, you can see that the extractor fans are still running even though that the process is off, and it's going to continue running until the timer has elapsed and then turn off the actual extractor fan. That there is the off-delay timer. Just come back offline. So the next timer that we're going to be having a look at is the pulse timer. That's this guy here, the S_pulse. Drag and drop that into this network, and then for the S7 style, it's SP. Drag and drop that into this network. Again, both timers require a timer number, T0 and T1, and then both timers require a time value, S5T hash 10S. S5T hash 10S. There we go. Let's save our work and then download this to the PLC and test it out. Go to goggles to view it live. Make sure I'm monitoring both networks. There we go. And what we're going to do here is just enable our start push button. And when we do that, you'll notice the timer begins to run and the output coil is already on. After 10 seconds, now the output coils then turn off and the timers reset, even though the input to the timers are still on. If I then just turn off my process run latch, the timers remain off. If I turn this back on and then turn it off, you'll notice the timers ran and then reset. So similar to the on-delay timer, it still requires a signal for it to fully run. However, what happens after it's timed out is that it turns off the outputs. So what a pulse does is it effectively pulses an output for a period of time. again, what we could use this for on the shop floor is when we start the process up, we might raise a siren or we might flash a beacon just to tell operators that the actual process is starting up as a warning. Now you don't want that running for the whole period of the process, so what we do is we pulse a siren or we flash a warning lamp for 10 seconds and then turn it off when the process is started. This is just to give operators or personnel on the shop floor indication that the process is starting to run. That there is the pulse timers. Now the next two timers are slightly different. The next two timers, we have the ODTS and the PEXT. The ODTS and the PEXT are different versions of the on-delay timer and the pulse timer. With these two timers, we don't need this latch in place. So what I'm going to do is I'm just going to delete this latch that we have. Instead of using M10.0 to control the process, I'm going to use my start push button M0.0. And I'm going to use my start push button here, M0.0. Delete these timers. And then add in the ODTS. And in this case, the SS. There we go. Now once again, both timers are asking you for a timer number and a timer value, S5T hash. I'll just say 15 seconds for this one. And again, T1, S5T hash 15 seconds. There we go. Save and download our work and let's see what happens here. Now, when we go online with this, when I modify my start push button to a logic 1, the timer will begin to run. If my start push button turns off at any point, the timer still remains running. It doesn't reset like a standard on delay does. And just to show you this, modify this to 1, modify it to 0. There we go. The signal to the timers are no longer on, but the timers are still running. 5, 4, 3, 2, 1, 0. Bang. And both lamps turn on. The input signals are no longer on. And these timers are slightly different. These timers are what they call latched on or retentive timers. They don't need the input signal on for all periods of time. All it needs it on for is one PLC scan. Now you'll notice with these timers, both output coils are on, both timers have elapsed, but how do we turn off the timers? The signals are already off. If I switch that back on, nothing happens. If I switch it back off, nothing happens. It still remains on. Unlike other timers, how they don't reset, these timers need a reset. If I just come back offline here, you'll notice on the S5 timer you've got an R. That R is a reset to the timer. If I assign this to M0.1, that will then allow me to reset that timer. If I save and download that and then go back online, there we go. If I modify my M0.1 to a logic 1, that will then reset T0 back to 0. There we go. Our timer has reset, our output coil is turned off. Looking at our SS timer, the S7 timer, however, it's still on. And you'll notice with this timer, there's no reset to assign to it. So what do? Well, if we come offline, what we're going to have to do is create a new network. And add in another normally open contact and tie this to M0.1, our stop push button. And we need to go to our BitLogic folder. Inside of our BitLogic folder, you'll notice there's an R coil. This is your reset coil. Drag and drop that into this network and then assign this to T1. This now becomes your reset for that timer. And this is where we start to see the downsides of these timers right here. You'll notice with this S5 timer, everything for this one piece of control is inside of one network. This timer, however, requires 3 networks for it to run. Now imagine you've got 20 timers in your process all needing to run very similar to this. If you're just using an S5 timer, you could use this in 20 networks. If you're using an S7 timer, however, you've got to use 60 networks to do the same job. This is why we prefer the S5 style over the S7 style, just because of its compact design. Everything's inside of that timer. We don't have to worry about anything else. We don't have to worry about adding in a reset. We don't have to worry about adding a contact to the coil. Everything is inside of one network. You've got your reset here. You've got your coil here. So let's just save that and download that to the PLC. Yep. Go online. There we go. Right, this timer's still on, so what I need to do is modify my stop push button to a logic 1, which triggers the reset, which resets timer 1, turns off the contact to timer 1, and turns off the coil. If I then 0 that contact once again, the reset turns off. I can now start my timers up again, and they'll begin to run. There we go. 6, 5, 4, 3, 2, 1. The output turns on. To reset it, all I need to do, toggle my stop push button, and that triggers the reset on both timers. That is the exact same design as this timer here. However, just like I said before, everything's in one network. It's nice and compact. Okay, so that's the latched on-delay timer. Finally, we've got our PEXT, which is the latched pulse timer. Just delete our ODTS and delete our SS, and now drag in our PEXT, and then drag in our SE. There we go. Type in here T0 and S5T hash, 10 seconds. There we go. T1, S5T hash, 10 seconds. And just like the ODTS, we can assign a reset to it. M0.1, and then here M0.1's already been assigned to our reset. Save our work, download that to the PLC, and then go online. Now, unlike the ODTS, the reset for this timer isn't 100% critical. You don't necessarily need to use it because this is a pulse timer, so it's going to turn off the output coil after the period of time has finished. The only time you need the reset is in case you want to reset it whilst it's still on and it's still timing out. But in most cases, if you're only going to run it for 10 seconds, 5 seconds, a short period of time, you may not necessarily need that reset. It's just a judgment call in that case. So what I'm going to do here, modify the start push button to a logic 1, 0 that, and you'll notice that the output coil is on. After the timer has finished running, 3, 2, 1, there we go, the output coil turns off and the timer resets. Again, you don't necessarily need that reset, but if we did modify that to 1, modify that to 0, and then want to reset it now, we could do so by triggering the reset to the timer, and that resets the timer back to 0 and then turns off the output coil. Again, a lot of people have their own preferences with Siemens timers. Some people prefer to use the S7 style over the S5 style. Personally, at Scantime, we prefer to use the S5 style just because everything is compact inside of one network. You still have the ability to tie a T0 contact to a coil if you wanted to, but everything can be done inside of one network, unlike these timers here. And then when you start getting into resets for these timers, then all you need inside of an S5 timer is just to assign the R, whilst in an S7 timer you need to create another network and then assign a reset to that. Now that there is Siemens timers. As I mentioned, Siemens have quite a few timers available. You've got 5 S5 timers, the on-delay, the off-delay, the pulse timer, the latched on-delay, and the latched pulse timer, and then you've got the S7 versions here. What we try to recommend if you're working with multiple PLCs to keep it straightforward for yourself is to stick with one timer. And that timer is the ODT timer. The on-delay timer is available inside of all PLCs on the shop floor. You don't need to worry about using a PEXT or an ODTS or an off-delay timer in other PLCs. You just have the ODT. Now, yes, other PLCs do have other timers available. Some have 3, some have 2, some have 1 timer available, but every PLC has the on-delay timer. So if you can comfortably use the on-delay timer inside a Siemens STEP7, then you could go to Mitsubishi GX-Works 2 and use the on-delay timer there because it works exactly the same. If you get used to using the pulse timer, the PEXT timer, the off-delay timer, and then you move to GX-Works 2 and you try to use those timers there, GX-Works 2 don't have all of those timers available. So then you've got to use a little bit of brain power to then try and work out how to create those timers using the on-delay timer. And what I'm going to do is I'm going to show you how to do that here. So let's just come off glasses and just delete all of our networks. Now, we're going to use the on-delay timer to create all of these different timers here, the other 4 timers available to us. Now, the first one that we're going to do is we're going to show you the on-delay timer as a LatchedOn delay timer. And a LatchedOn delay timer is exactly what we've been doing. A LatchedOn delay timer uses a standard control latch, M0.0, M10.0, M0.1, M10.0. We have our standard control latch, and then all we do is we tie the latching bit to the timer itself, T0 S5T hash 10 seconds, and then tie our output coil to Q4.0. So by itself, this is the on-delay timer. Remember, the on-delay timer doesn't latch itself on. It needs the input signal on at all times. So if we just had this to a physical input, the operator would have to have that physical input engaged for the full period of time. If that turned off at any point, it would reset the timer. So what Siemens gave you is the on-delay latched timer. But again, in other PLCs, you don't have that. So how do you create that timer? You create it with this design here. This is the latched on-delay timer. If we download this to the PLC, we ran it just before, but we'll just run it again quickly to show you how it works again. Our input signal is only going to be on for a period of time. There you go. Our input signal is only on for about a second there. Our timer is still running just like the latched on-delay timer would do. And then the output coil will then turn on after 10 seconds. And we got our reset signal just like our latched on-delay timer as our stop push button. That there is the latched on-delay timer inside a Siemens. Next is your pulse timer. So again, if I just come offline here, delete our latch, tie this to M0.0, our input signal, and we have our on-delay timer here. Now what we want to do is we want to create a pulse. So what I want to do is I want to turn on our start push button, and when it's on, the output coil turns on as well. At the same time, we are running a timer in the background, our ODT, T0, S5T hash 10S, and that there is going to turn on an internal bit, and we'll just call this M0.1. When this contact is turned on for 10 seconds, we then turn on our stop signal, which then opens up our contact here and then turns off our output coil. And this here is exactly the same design as your pulse timer. Let's just save and download this to the PLC. Again, remember how your pulse timer works. When your start signal turns on, the timer begins to run. After the period of time, 10 seconds, the output coil turns off. So let's watch this in effect. Modify to 1. Our lamp turns on. Our timer's running in the background. 10 seconds later, our stop push button will turn on. Open this up and then turn off our lamp. And there we go. That's your pulse timer. So how do we design the latched pulse timer? It's dead easy, guys. All we do, create a new network and create your start stop latch once again. So M0.0, M10.0, M0.1, M10.0. Instead of using your start push button here, all we're going to do is we're going to use our M10.0. Now what we don't want to do is use our stop push button as the output coil this time. What we're going to do is we're going to use another M bit, M0.2, and that there will reset the lamp itself. So now what we're going to do is use this M0.2 to then reset our process when it's finished. There we go. So what's going to happen here is when our start push button turns on, our process run will turn on and begin to run our timer and turn on our lamp. Our start push button can turn off now. It's in the hands of our latch. When this timer has finished running, M0.2 will turn on. It'll open this contact here and turn off the lamp. It'll open this contact here and then reset our process. Let's just save it and then download this to the PLC. Alright, let's start this up. There we go. Our start push button turned on just for a second. Our lamp is now on and running. The timer is now running. And then our lamp now turns off. Our process run turns off. Everything resets back to its original state. And that there is your latched pulse timer with just the on delay. Next is the off delay timer to design. And the off delay timer is probably the most complicated timer to design. Let's come offline first of all, and then let's just delete everything as we've got it, creating a new network. Now let's think about how this timer works. When the input signal turns on, it turns on our output coil and keeps it on. And it remains on until the input signal is turned off and the timer has elapsed. So this is going to involve some sort of latch. So we're going to have our input signal being our M0.0. We're going to have a normally closed contact going through here. And then we're going to have our Q4.0 being latched on. Like so. There we go. I'm going to leave this reset as blank for now. When the start push button turns on, that there latches on the lamp. Now what we needed to do is detect when the start push button has turned off. To do this, we need to use a bit logic instruction, which is your negative flag. Your negative flag detects the falling edge of the actual input signal. So create a new network, normally open contact assigned to your start push button. And what we need to do is detect when this signal turns off using this flag here, which is your negative falling edge pulse. Drag and drop this in to place, and then give this an M-bit address. This M-bit address is a storage bit. If you want to learn more about these bits, what I suggest you doing is going to our online courses and having a look at the STEP7 professional programming series, where we cover these other instructions inside of Siemens. I'm not going to go into too much detail on how this signal works though. Just tie this to, let's just say, M0.5, just a storage bit address, and then tie this to another output coil, which is then going to be M0.3, for example. So what's going to happen here is when our start push button turns on, this negative falling edge signal is going to wait for the start push button to turn off. When it turns off, it's going to pulse our M0.3, and what we want to do is we want to latch on M0.3. And we're going to use this bit to control our timer. So M0.3. Again, we're going to need a normally closed contact here to reset our latch. Not too sure what this is going to be just yet. Create another network. And then use a normally open contact addressed to M0.3. When M0.3 turns on, what I want to do is I then want to use our OnDelay Timer. T0, set for S5T hash, 10 seconds, and then after that's finished, turn on another bit, which will be our M0.2, our stop signal, and that M0.2 is then going to reset our lamp, and it's then going to reset our negative falling edge latch. So this has 3 networks to create that off delay timer. Like I say, it's a little bit more complex because we've got to detect the negative falling edge. So what's going to happen here is when our start push button turns on, this contact will close. It's then going to turn on our lamp, and our lamp is going to turn on and stay on. Nothing else will happen. Our timer won't run because M0.3 isn't on just yet. It's then going to wait until our start push button turns off. And when our start push button turns off, our negative falling edge instruction is going to pulse our M0.3 for 1 PLC scan. So we are latching this on to detect this. When M0.3 turns on, our timer begins to run for 10 seconds. After 10 seconds, M0.2 turns on, resets our lamp, resets our negative falling edge latch. So let's save our work and then download this. Now remember how the off delay works. The off delay runs an output, let's say an extraction fan, until the process is stopped. When the process is stopped and the input signal turns off, the extraction fan remains on for a period of 10 seconds. After 10 seconds, it then turns off. So let's go to our goggles there. Let's turn on our start push button, and there you go. Our lamp is on, our timer isn't running, everything else is as it was. Like I say, let's say that was our process running signal. Our process is currently running, our extraction fan is currently on. When our process run turns off, however, that is when this flag is turned on, our timer begins to run. 3, 2, 1, it then resets our lamp. And we're ready to go once again. If I then start this up again, our latch turns on, our extraction motor is now running, turn this off, and it begins to time out. When it's timed out, our extraction motor turns off, and we're back to the beginning again. There we go. And that there is designing all of the other timers inside of Siemens using just the on-delay timer. And like I say, the reason why we need to be able to do this is because if you go to work with another PLC, if you go to work with an older PLC especially, where they don't have all of these timers available to you, you'll only have the on-delay timer. And if you need to design a routine to do this, then you're going to need to be able to understand how to use that on-delay timer in a way to create those other timers. And that there, guys, is Siemens timers. That is showing you S5 timers, S7 timers. As I mentioned before, we prefer the S5 timers because everything's in a compact design. And then showing you how we can just use a standard on-delay timer to create all of the other timers available with just a little bit of logic inside of the PLC. As I mentioned, if you want to learn more about the other instructions inside of Siemens, similar to that negative falling edge instruction and the other ones, and as I mentioned before, if you want to learn more about Siemens instructions like that negative falling edge and others, then what I would recommend doing is having a look at our Siemens programming online course, the STEP7 version of that. And that there will teach you about STEP7, and it will teach you about the other instructions inside of STEP7 and how to use them inside of programs. And it'll go more in detail about that negative falling edge instruction there. Once again, I've been Chris, and I look forward to seeing you again next time.